Now you can see my screen.
Yes, sir.
Nakul? Okay, fine. So what is the name of this compound? You draw the structure properly. This is the structure given in your book or in some competition examination multiple choice questions. Four options are given. Now tell me, what is the name of this compound? Yeah.
So one bromo, two, one bromo, two in bracket, one methyl propyl benzene, sir.
Okay. What we do is we first of all draw the structure here. At this is the bromo here, and this is the CH. This is the branching here. Then we have a CH2. Then we have CH3. Okay.
Yes, sir.
Now this is the structure that we have drawn. Okay. Now name this compound.
So one bromo, two, one dash methyl
Mm,
propyl
mm.
benzene, sir.
Okay. One bromo. This is the one, two, three. So it is it on the two position you have
One methyl
methyl
propyl
propyl. Good.
benzene, sir.
Benzene. Everybody okay now? Understood? Okay. Now one more question I'm giving you. Then we'll go to the next type of the question because I'll discuss different type of the questions today.
Yes.
Okay. Yeah, try this question, please. I want you to answer.
Sir,
Yeah.
is it 3-chloro-5-methyl hex 2-ene?
Can we expand like this first of all?
So I think it is 3 chloro
Wait,
2
wait, wait,
methyl.
wait. First of all, let us expand this. Okay.
Yes.
Okay. Now name it. We are doing the numbering now from
From
the
left to right,
from this side. 1, 2, 3, 4, 5, and 6. Okay, then.
then 3-chloro-5-methyl
Okay. 3 chloro 5 methyl. Then
hex 2-ene.
hex 2 in. Everybody comfortable with this answer now? Okay,
Yes.
understood. Right. Now, I'm giving you one question here. This is A, B, C. Out of these three compounds, which has the highest dipole moment? CHCl3. Which has the highest dipole moment and why? And D option is all have equal dipole moment.
So is it B?
B.
See, first of all, draw the structure. All of these are sp3 hybridized,
Yes.
right? So that is tetrahedral. Now you tell me, A, B, C, what?
So A?
A, sir. Sorry.
A. In case of the C, I first of all talk about C. The resultant of the two is in this direction, right? The resultant of this is in the two direction, and now you can see it is a null vector operating here. It's a separate. It is a symmetrical molecule, so dipole moment will be equal to 0. Right? The molecule is symmetrical, and for all the symmetrical molecule, dipole moment is equal to 0. And here, whenever we have dipole moment in two different directions, we can find out the resultant, right? So resultant vector will be right in between the two. Here it is scattered in between the three. It is maximum for A. Okay.
Yes.
Okay. Now another question I'm discussing here. I have a molecular formula that is C5H10. It does not react with chlorine in the dark, but it gives single monochloro compound with C5H9Cl in the bright sunlight. Identify the compound. Which compound is this? I have given the molecular formula only. Tell me what is the structure of this compound.
Hello, sir. Sorry, I was a little late to join. Um,
Okay.
could you just tell me what we are doing today?
Today we are revising and doing the question practice of the haloalkane halorine. Okay.
Okay, sir. Okay, sir. Okay.
So today the last class of our syllabus. We are doing it. Next time onwards, we'll be discussing test series discussions. Right. Okay. Now the question here is: I have a molecular formula C5H10. It does not react to the chlorine in the dark, but it gives one monochloro single derivative compound in the presence of sunlight. What is the possible compound of this compound? Possible structure of the compound?
Cyclopentene. Pentane, sir.
Cyclopentane. Cyclopentane. So it's a cyclopentane. It does not act with the light in the dark. All the alkanes react only in the presence of sunlight. So if I go for the single monochlorination here, whether you do it at any of the 5 carbon atom, you'll get the same compound. Okay.
Yes.
Oh, sir.
Yes, please.
So can you explain why it doesn't react with chlorine in the dark?
Okay. See, in the alkane, if it is an alkane, if it is the alkane, that will undergo free radical mechanism, free radical substitution mechanism. And for the first free radical substitution, the first step is we have to break this bond in the presence of light, and we get a free radical here. The first step require light, and in the dark, the first step cannot take place.
Oh, okay,
Right,
sir.
that is why. And moreover, if we see the molecular formula here, it is a CnH2n that represent either it is alkene or it's a cycloalkane, right? It can be alkane or it can be alkene, right? So it does not react in the dark. It means that should not be alkene. That also it can be only alkane.
Yes.
That can take
Yes,
place in
sir.
the presence of light. Okay, now come to the next type of the question. Are you comfortable with the mechanism SN1 and SN2?
Yes, sir. Comfortable,
Okay,
sir.
okay. Everyone, I want everyone to do. If you find difficulty, let me know. I can repeat it. Otherwise, I'm coming to the question part of it. Everyone, I'm stopping sharing for some time. Yes. Write in the chat. All good. If you're comfortable with the mechanism SN1 and SN2.
Oh, sir.
Yes, please.
Can you briefly explain them?
Yeah, that's good. That's good. That's what I want. That if you are not fully confident about anything, just let me know. Today I can discuss that. That's good. First of
Sir,
all,
will you be having other discussion classes like this, or like?
see, today was a day that was like we had an extra class today. So we had, otherwise, we are planning the nomenclature discussion of the test series from the next time. You want this type of class, right?
Like each chapter revision, like
Yes, yes,
weekly
yes,
activity.
yes. I understand. So what I have planned for you, and what thing is, we are going to discuss the test first, right?
Yes, sir. Surely.
Right.
The test discussion.
Test
Okay, fine.
discussion, and along with the test, if you find difficult that this particular question is not clear, this particular mechanism is not clear, then I'll go into detail of that. Right. So
Okay,
if time is left, then I can discuss some more questions also. Right.
sure, sir.
More your doubts also. Will enough time. Right. Don't worry.
Sure, sir.
Not. But today's class is good one, right? useful.
Yes, sir, because it's like a chapter full revision, so it's like a full summary because
Yeah,
we
yeah,
revised it. So
yeah.
that's
I'm not also doing the summary part. I'm doing it your problematic area. I know what type of
yes,
questions
sir.
are there.
Yes, sir. Thank you, sir.
So SN1 type of mechanism. When I say SN1, that means it is a one stand for unimolecular. Whenever I say unimolecular, then you should correlate with the term that we had discussed in the chemical kinetics. Unimolecular means the rate of reaction depends upon the one molecule, and the nucleophile will come and go for substitution. Nucleophilic means first of all the nucleophile will attack and that will cause the substitution. So we call it a nucleophilic substitution reaction. Now, why unimolecular? Why it depend upon one molecule? Under what conditions? This is a 3-degree haloalkane, right? 3-degree haloalkane, tertiary haloalkane. The first step is removal of the Cl negative from here and formation of a carbocation. Formation of carbocation. This carbocation and the carbon carrying positive charge is sp2 hybridized. I'm talking about this carbon atom, the carbon which carries the positive charge. And so the geometry of the compound is trigonal planar. And on this trigonal planar, now the nucleophile is negatively charged or it may be neutral but with a lone pair, that will attack upon something positive. Nucleo means positive, phile means loving. It can attack on this carbon positive from the two sides, either from the left hand side or from the two side on the other side. Because the molecule is planar, on the one plane it can from the left and right both ways. So the two product will be obtained here. One is attack of the nucleophile from the right hand side, other from the left hand side. Now you will say what's the difference, right?
Optical
Right,
vision.
yeah, optical, yes, only that part is there. So in this reaction, the two-step process, the first one is slow and second step is fast. Rate of reaction depends upon which step, slow or fast.
Slow step.
Slow step. In
Slow
the
step.
slow step, we have only one reactant, that is the haloalkane. It means it does not depend upon the concentration of the nucleophile, but it depends only upon the concentration of the haloalkane. Right? So it is equal to K into Rx. It depends upon only one molecule. So I can say order of reaction is equal to 1. And that is why we say it is SN1. While writing SN1, you must be very careful. S in the subscript it is 1, N in the superscript of the N there is a 1. Don't write it like SN1, that will be wrong. The right representation is in the subscript of the S write N, in the superscript of N write 1. SN1,
Yes.
right? So rate of reaction depends upon one molecule now, right? That is why we call it the unimolecular. What is the reaction intermediate here? What is the reaction intermediate here?
3-degree carbocation.
Yeah, carbocation. I should say carbocation, right? Intermediate is the carbocation. And you know that you have a primary carbocation, secondary carbocation, tertiary carbocation. Primary carbocation will be obtained from the primary haloalkane. Secondary carbocation will be obtained from the secondary carbocation, and tertiary carbocation will be obtained from the tertiary carbocation, right? So tell me, like, which haloalkane gives the most stable carbocation?
3 degree.
3-degree, and the reaction whose intermediate is stable occurs fast. Whose intermediate is stable, that occurs fast, right? That takes place fast.
Yes.
So it means 3-degree haloalkane will be reacting than the faster than the secondary, then clear. The order of rate
Yes.
of reaction will be like this.
Done, sir.
right? And this is the leaving group. The chlorine is the leaving group. If the group that leaves easily, that will be making the reaction fast. So if we have RF, RCl, RBr, and RI, which will be leaving the group, which is the best leaving group?
Ri, because the bond length is the most.
RI. Yeah, RI is the better leaving group, right? RII is the better leaving group because of a bigger size, right?
Yes.
So this is the leaving group now. Now back to this one, back to the mechanism again. If you see the configuration here, the chlorine on this right hand side, and here also nucleophile also on on the same side. So I can say from here to here we have a retention of configuration, right? And the other way from this to this, it is opposite. On the opposite side, I can say here we have an inversion of configuration. So two things are happening here. One, retention, and second, inversion. Retention and inversion of configuration is observed here, right?
Yes.
And second thing is, if this is dextrorotatory, this will also be dextrorotatory, but this will be levorotatory. So the product will have equal amount of dextro and levo amount. So dextro concentration, levo concentration, if they are equal, what do you call such type of solution?
Racemic mixture.
Racemic mixture. Racemic mixture. Will it be optically active or not?
Yes.
Don't you think that the dextro will be counterpart by the levo and levo will be
Mostly, yes.
compensated
It
by the
will be
dextro?
optically
Yeah,
inactive.
it will be optically inactive. Optically inactive due to external compensation. We call it external compensation. We call it external compensation.
Clear, sir.
All right. This was the SN1. Just briefly, I had discussed here. Now we can discuss about the SN2. What is the meaning of the word SN2 now? Two stand for.
Reaction is to
Two stand for
Bimolecular.
bimolecular. Yeah. When I say bimolecular, it means rate of reaction depends upon
Concentration of haloalkane and nucleophile.
bimolecular means rate of reaction depends upon the two component here, right?
yes.
So here I choose a primary type of haloalkane. In this case, if I remove the chlorine, it'll give you a it'll give you a primary carbocation, methyl carbocation. Is it stable or not?
Compared to other, no, sir.
No.
Less.
Least stable, very less stability. So this will not take place at all. So the nucleophile will attack on the carbon on the positive center like this from the opposite side. Chlorine from here, the nucleophile attacking, right? Like this.
Yes, sir.
It will attack from the back side. It will not attack from the front side because of two reasons. Number one, steric hindrance, and number two, there is a negative charge here, negative charge here. They will repelling each other.
Clear, sir.
Right. So Cl negative out. and now nucleophile is formed here. The two-step process, the first step is slow and second step is fast.
Yes.
Rate of reaction depends upon
Nucleophile.
slow step. In the slow step, we have two things. One is the Rx, other is the nucleophile. Right?
Yes.
So that is why we say it is the order is equal to 2. 1 plus 1, 2. And so we call it say SN2 type of reaction. And the intermediate is this transition state where the old bonds are being broken and new bonds are being formed.
Yes.
So you can see this is formed the nucleophile attacks upon the carbon. If in place of this H there is a R group, the steric hindrance will increase. If the hindrance increases, reactivity will decrease. If further R added here, hindrance will further increase. If further R is there, it will further hindrance will further increase, and the attack will become difficult and difficult. So, what type of haloalkane will be reacting faster here?
Primary.
Primary, yeah. So, the order of rate of reaction. Primary haloalkane. Then we have secondary haloalkane. Then we have 3-degree haloalkane. Everyone getting me?
Yes.
Sir.
Yeah.
So, but what about for 2 degree? Like, will it undergo SN1 or SN2?
Yeah. That's very good question. I will say if it is a primary, it'll surely go by the SN2. If it is a 3-degree, it'll surely go by the SN1. Because in 3-degree, we have a more stable carbocation. In the right, in the primary, we have more least steric hindrance. But in case of secondary haloalkane, it can take place both ways. SN2 as well as by the SN1, depending upon nature of solvent. In the polar solvent, sorry, in the non-polar solvent, SN2. SN1 for the polar solvent. Am I clear?
Yes, sir.
Yes.
Right. Now, in this
So 1 second, can you show that last slide?
this one, yeah.
Thank you.
All right. So again, coming back to this, again you can see that here we have reactant chlorine on the right hand side and nucleophile on the opposite side. I can see here we have inversion of configuration,
Yes.
but not retention of configuration. Okay.
Yes.
Okay. Now, so if this is a dextro, it will be levo.
Yes.
Right. This is what we are observing here. Okay. Now I am giving you one question. I have C6H5, CH2Cl, and we have a C6H5, CHCl. Again, we have a C6H5. Out of these two, which can be easily hydrolyzed with aqueous KOH? which will be easily hydrolyzed with aqueous KOH. And why?
So is it the second one?
Reason.
Second one.
Reason.
So it's a
Uh,
tertiary carbon.
It's a tertiary carbocation. Okay.
it has greater resonating structures.
So
Good. Good. After losing the CHCl, it will get a benzyl carbocation. Right. And after losing here the Cl, it will become a more stabilized, more stable intermediate. Right. More
yes,
resonance stabilized. More resonance stabilized. So the reaction whose intermediate is more stable, that takes place faster.
yes.
All right. Okay. Now next. Now another question I'm giving you. Can you tell me how to increase the number of the carbon atoms in the chain?
By using Wood's reaction.
Okay, number one is the Wood's reaction. Tell me about Wood's reaction. What is the reactant for the Wood's reaction?
Sodium and dry ethers.
What is the main organic compound? You're telling me what is on the arrow, right?
Yes,
Yeah,
haloalkanes.
good. How many?
2 moles.
2 moles. And what is the product here?
R
Alkane with
R
alkane, yeah, with 2 NX. Okay, any other way?
Friedel-Crafts alkylation and acylation.
Yes, Friedel-Crafts alkylation can do, yeah. But that will be adding alkane carbon chain to the aromatic compound, right? Benzene plus I can add here RCl, right? In
Yes,
the
sir.
presence of anhydrous aluminum chloride. You are right. We are adding carbon chain to the benzene ring now. Good. Okay. Good. Another way. I want everybody to participate in my class. How many students are there right now? Let me see. Wait a minute, please. So many. Ajay, Bijoy, Akhilan, you're not participating. Okay. Everyone, please participate. Huh? Okay, who is participating? One is Saksham. Second, I can hear two voices. Saksham.
Some
Yes, sir.
Okay, Rahul, okay, Ryan, Nakul. These three. Okay, I want everyone. Huh? Okay, no problem. Shisha, Shesha.
Yes, sir.
Yeah. If you fail, you can also participate. Huh? If you're not getting anything, let me know.
Yes.
Okay. Okay. Now tell me the other way how we can increase number of carbon atoms.
The fitting reaction.
Tell me about the fitting reaction.
Haloalkane. Yeah, no, haloarine and Na plus dry ether.
Uh, okay. Fitting reaction. So two molecules will combine here and diphenyl will be obtained. You mean this?
Yes.
Yes.
Okay. Good. Any other?
Then Wood's fitting reaction.
If I want to increase the number of carbon atom by just by one, what should I do?
React it with KCN.
Yes. RX with alcoholic potassium cyanide. It'll give you RCN. Good. Okay. If I want to increase the number of carbon atom by any number,
Sir, didn't get your questions.
suppose I have here this and I want to increase the number of carbon atom by let it be four other carbon atom. How can we do that?
Sir, can you tell this one?
Okay. For that, I can add sodium acetylide. You can add here any number of carbon atom here and go for the nucleophilic substitution reaction. You can see CH2 CH2 and after that I can add here and I can add here now n number of carbon atoms here. Whatever I want.
Okay, sir.
Understood?
Yes, sir.
Now, my question is you have to convert ethanol to but1ine. How to do it?
Oh, sir.
Yes.
So can we first treat it with SOCl2?
Okay, here. Okay. SOCl2. Then what is the possible product?
C2H5Cl.
Very good.
Then Na and dry ether, Woods reaction. Then
Na and
dry ether,
okay, Na and triether. What it will give?
butane.
Butane. Okay.
Then
Then
um, then react it with Cl2 and light.
okay. Then what is the possible product now?
CH3, CH2, CH2, CH2Cl.
Last means we want to put the
Yes, sir.
chlorine at the number last. Okay.
Then can we react it twice with alcoholic KOH?
Okay. Then it will give you alkene.
Yes, sir.
But that is not my answer. I want butane. Ine means triple bond. I
Okay.
want this thing.
So just confirming, so instead of chlorinating in the presence of light, can we do anti-Markovnikov rule? Can we apply anti-Markovnikov rule twice with HBr?
Okay, wait. Anti-Markovnikov rule applicable only with the alkene and HBr, right? Unsymmetrical alkene and HBr. It is not
Okay.
alkene.
Yes, sir, yes.
Okay, I'm telling you one thing, very shortcut. Don't do this step, don't do this step, don't do this step. Up to this, you are right. Now you simply add HC triple bond CNA. Right now, I told you this technique. Yes or no? I got the
So,
butane. One step process.
yes,
Right. Okay. One thing more. One thing more. Actually, you're also not wrong. You're also not wrong. But your method will be going wrong. I tell you how. Up to this, you're not wrong, but you're not going ahead with that. Right. What you do is you add here bromine or chlorine. Across the double bond, you will get a bromine here, right? In the presence of the carbon tetrachloride. Yes or no?
yes,
Yes, sir.
And then you go for the alcoholic KOH 2 times, 2 mole. From one time, what will happen? HBr will go, double bond is formed. Another time again, HBr will go and double bond, triple bond will be formed. Again, you will get a triple bond. But you're not going these two steps once more. This is a lengthy method, but you could do it. We just stopped at in the middle,
Yes, sir.
right? You are not wrong, but you could not complete it. Otherwise, you can do it in one step also. There is expert, you know, expert practice.
Yes, sir.
yes,
That you can do that. Okay, let us go for once more. Right? What type of question right now expected in the multiple choice question? Right? What is the reagent here? What is the reagent here? What is something? If you a question on what is the reagent here, then you will be stuck. That how can you do it in one step if you don't know the function of the sodium alkyd? Right?
yes,
Okay, then I'm
So
coming
can you
to
take the previous page?
sure. You want to note down?
Yes, sir.
Yeah.
So what is again? Can you repeat the name of NaC triple bond Cr?
Sodium acetylide. This is known as sodium
Okay.
acetylide. ACETYLIDE.
Yes.
Now, next. Convert propene to propine. Propene to propine.
So just now you showed, right?
Yeah, that's what I thought. 1, 2, 3. Propene is there. So you just add here bromine in the presence of the carbon tetrachloride. You will get a double 2 bromine across a double bond, right? Then you just add here 2 moles of the alcoholic AOH.
Yes, sir.
Double dehydrohalogenation will take place and alkyne will be formed. Yes or no?
Yes, sir.
Everyone comfortable? Done?
Yes, sir. Done.
Yes, sir.
Okay. Convert toluene to benzyl alcohol.
So Cl2 in light, then aqueous KOH.
Good. Toluene is benzene with a CH3 group, right?
Yes.
Then chlorine in the presence of light will give you this one. Then at the aqueous KOH you will get here. Okay.
Yes.
Okay. Now convert benzyl alcohol. I repeat, benzyl alcohol CH2 to 2-phenyl ethanoic acid. I had drawn the structure.
So
Hmm.
is it SOCl2, then HCN, then complete hydrolysis?
Repeat.
So first SOCl2,
Hmm. But
uh,
okay. What will I get here?
uh, CH2Cl,
Okay.
yeah. Then HCN,
SCN or
I
KCN.
mean KCN,
Yeah. Yeah. You're right.
um, then complete hydrolysis.
Very nice. Perfect. Understood?
Yes, sir. That's clear.
Okay. Convert aniline to chlorobenzene. What is aniline?
Benzene with NH2.
Good. Hmm. And chlorobenzene is this one, right? Tell me what we can do.
So first diazotest. I mean, what? Uh, so so NaNO2 plus HCl 0 to 5 degrees Celsius, then CuCl,
What do you call this process?
diazotization,
Yes, diazotization. What will you get here?
uh, benzene diazonium chloride,
Chloride. Okay. Then what
then
next?
CuCl2,
CO2, Cl2.
2Cl2,
Hmm. What do you call this reaction?
Sandmeyer's
Friend
reaction.
reaction. Yeah. Any other way? Copper powder with HCl. What do you call that reaction? What do you call that reaction? Getterman reaction. Okay, got it?
Yes.
Yes, sir.
All right. Okay, I'm now giving you this starting material and now acting with alcoholic AOH. Tell me the product.
Butanine and butene.
Which is the most stable product out of the two?
Butene.
Why so? Why this is the major product? Why this the minor product now?
So because removal of secondary hydrogen is much more easier than the removal of primary hydrogens
Any
due
an,
to the stability.
any particular you're not giving the right answer exactly. You're right, it's a major product, but why so? Do you know about the Sadzev rule? Yes or no?
Yes.
Sadzev rule. What is the rule statement here?
The H plus atom is eliminated from the beta carbon having less number of hydrogen
No,
atoms.
no, no. Whenever we have, there are two possibilities of the alkene formation. Then that alkene will be formed that is more alkylated. I'm using a word more alkylated. That will be the major product. Here the double bond is alkylated from the two side, and here it is from the one side. So which will be formed?
From the two sides.
And now it means this is more stable. Can you tell me why is this alkene more stable?
Due to the dipole moment being stabilized.
No. Do you know concept of the hyperconjugation?
Yes, sir.
Right. More the hyperconjugate structure, more the alpha hydrogen atom, more the hyperconjugate structure, more the stability.
Yes, sir. Yes, sir.
Right.
Clear, sir.
Okay. Now I'm giving you one question, one statement. I'm giving you. You note down the statement. Right. I'll be writing it briefly here. Primary alkyl halide having the journal formula C4H9Br reacts with alcoholic KOH to give a compound B. This is a compound A, this gives a compound B. Compound B is treated with the HBr to give a compound C. B and C are isomers of each other. When A was reacted with sodium in the presence of the dry ether, it gives a compound D with the molecular formula C8H18. That was different than a compound when N-butyl bromide was reacted with sodium. Identify ABCD.
In this
Identify
given statement, it will be A and C are isomers, right?
B and C are isomers. Yeah. A and just isomer of A. Yeah, B and A are isomers. Identify the A and B and C.
So A and C should be isomers, right? B will be alkenes. Alkenes.
Yeah. A and C. Yeah, A and C. Yes. Okay.
So A is 1 bromobutane, B is 1 butene, C is 2
Wait,
bromobutane.
wait, 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 wait. Everyone, work upon it. I'm giving you 2 minutes. First of all, you just try it. Then I come back to this. Yeah.
So A is 1 bromobutane.
See, if you make it one bromobutane, that's basically N-butyl bromide, right?
Yes.
It says this is different. It means the A is different from the N-butyl bromide. This is not possible. The question statement is already told this statement that one bromobutane or butyl bromide is not. Should I tell you now?
1 second, sir.
Okay. Should I help you now?
A will be, sir, 2-bromobutane.
2-bromobutane. Okay, let us work with your statement now. 2-bromobutane. If we take up this molecule as A, okay, with alcoholic KH, what it will give you? What it will give you as a major product? It will give you
Major will
butene.
be the
It'll
butane.
butene, right? And if I again add here HBr, will it not give the same thing back? But I want isomer. It means this is again wrong. Getting me, Saksham?
So if we go by the Hoffman's product,
See, even if you go by the Hoffman product, okay, let us see. If you said, okay, I will make this one. Now, if you add HBr, then you will apply the
or
Now you will apply the Markovnikov rule. Yes or no?
yes, yes, sir.
Again, you'll get the same product. Even if you apply the Hoffman product, otherwise that is not applicable. Even then your answer is going wrong. It means this is also wrong. Yes or no?
Yes, sir.
Okay. Now I'm removing this. Think about something different now. Everybody getting me?
Yes.
Yeah. Now, yes.
So can you solve it now?
If you
Because
take,
I had these two suggestions.
okay, if you have this A, work upon it with alcoholic AOH, it will give you this one.
Yes, sir.
And now if you add here HBr, Markovnikov rule product will be formed. And what do you find here? This is the A, this is the B, this is the C. C and A are isomers.
Yes, sir.
Okay. Now, if you go for the sodium with a dry ether, it will be different product as obtained from the N-butyl bromide.
Yes, sir.
Two such molecule will combine together. One this part, another this part. Yes or no?
Yes, sir.
It means this is my A, this is B, this is C, and this is D.
Clear, sir.
Understood? Okay. Okay. I should give you this type of questions, na? This will be more challenging. Huh?
Yes, sir.
Okay. I have a molecular formula C7H8, right? It is treated with chlorine in the presence of FeCl3. Some B product is formed. You have to identify both A and B. B and C, two products are formed. Basically, in this question, more focus is on the reagent.
Sir, can you repeat what is below Cl2?
Yeah, Cl2 and anhydrous FeCl3.
Okay, sir.
Do you know the function of this anhydrous FeCl3?
No, sir.
No. In place of it, if I write anhydrous aluminum chloride, then you know it.
Reducing agents.
No. The function of this is to generate an electrophile like
Oh, right.
this, right?
Sorry, sir. Yes,
Got
sir.
it now. It means basically something electrophilic substitution has to take place,
Yes, sir.
and that is also on the aromatic compounds. So work upon this. Hmm. Okay, now I'm giving you this option.
Sir, ortho and para
No, no, no.
chloroaniline.
This is the product.
B is ortho chloroaniline and C.
And how come aniline?
No, sir, not alanine. My bad, sir.
Toluene. Huh?
And
This
yeah,
toluene.
toluene.
Toluene. So first A is this. Then you have ortho and para chlorotoluene.
Yes,
Understood?
yes, sir, clear.
Right. I'm stopping sharing for some time. Just give me a second, please. Just give me a second. Let me. Yeah. Again, I'm sharing my screen with you. And let me open this one now. Okay, this is the question practice assignment that we have been given. Okay, now start with this question. How many questions are there? Let me check. Okay, enough. Okay, fine. Let us focus upon the question number 1.
So option A, right?
Option A.
Good. Second question.
Option A.
Option A. Everybody clear?
Yes.
Nicole, Ryan.
Yes, sir.
Okay. Number 3.
Option B.
Option B. No, we're called not doing the numbering from now.
So from left.
1, 2, 3, 4, 5. So
Yes,
that
sir.
should be none of these. No.
So shouldn't double
Okay.
bond be
2
option?
bromo. That should be 2 bromo. 3. Oh, double bond should be preferred. Huh?
Yes, sir.
Yes, sir.
So go by this way then. 1, 2, 3, 4, and 5. Then
Yes,
we
sir.
have 4 bromo, 3 methyl pentene, right? Understood.
Yes,
Go,
sir.
go to number 4. Which is not an allylic halide.
Option D.
So can you explain this one for me?
Allylic means what? Allylic means this is an allyl group, right? So if I make the structure here pent 1, 2, 3, 4, 5, and make the numbering here 1, 2, 3, 4, 5. Make it as a 4 bromo and pent 2 in. So this is 1, 2, 3. Yes, this is a allylic. See here, double bond. Next carbon atom, halogen is there. So this is allylic. Got it? Now question is, which is
Yes.
not allylic. Let us draw the structure second one now. 1, 2, 3, 4. 1, 2, 3, 4. 3 bromo. 2 methyl. But 1 in. Yes, it is also allylic. On the next to the double bond, this is followed here. This is allylic. But if I go for the 1 bromo but 2 in, 1, 2, 3, 4. 1 bromo but 2 in. This is also allylic. You can see third carbon atom. Allylic group. 1, 2, 3, 4. But 1 in and 4 bromo. This is not allylic. On the third carbon atom, there should be halogen. So this is not allylic now. Understood?
Yes. Yes.
Go to number 5. Just a minute, please. I'll be back in a minute. Huh? Just do this fifth, sixth, and 10th, 11th, which are visible now, right? 4 questions. I'll just back in a minute only. Yes, have you done? Yes, hello. Are you there with me?
Yes, sir.
Hmm. Fifth question. What's the answer? What is this one?
Toluene.
Okay. Then this is. It may be ortho, it may be para, right? Uh, okay, let us take it. Something wrong.
So won't toluene undergo side chain chlorination? Or Cl2 in presence of
Yeah. Then bromination. Para product. Bromine here. ZnCl2. Again, the chlorine will be removed. But para bromotoluene. Yeah. See.
So can you explain what happens in the third reaction, Zn in presence
Only
of H?
this is a reducing agent, right? The chlorine here is removed and H is added here. This is reduction. Addition of hydrogen, removal of the electronegative element is called reduction.
Yes, sir.
So hydrogen chlorine is replaced and we are adding here hydrogen.
Yes, sir.
Sixth question.
D.
Yeah. Getting me? Everyone? Taksham? Ryan?
Yes, sir.
Yes,
Yes.
sir.
Okay. Then I told you to do the 10th and 11th question. Okay, not. Tell me the right answer here. This is a causing the minus R effect, so it is a meta director. It means P should be meta bromo. And this is a reducing agent. NO2 will be now reduced to the aniline here. It means that should be
D.
D option. 11th question. Best synthesis for. Okay, it is showing only two options. Is this a right way? Like out of the 1 and 2. I want to prepare 1 bromo, 3 chloro. If I go by the 1,
Option 1 is not right, sir.
option 1 is not right. Okay.
Sir, can you scroll down a bit?
What about B? Check for the B.
Yes, sir. That's why I'm asking to see for other options, sir.
First check for the B. Then I'll show you the third one also. Shall we try the B? It's a meta director.
Yes, sir.
So it should be chlorine here. Then reduction, it will be converted into aniline. Then HONO, it will convert to the nitro benzene diazonium chloride. CuBr2, it will convert to the bromo. Oh, my product is obtained. Ketterman reaction.
But can you repeat what does HONO do does?
It is a basically obtained by the NaNO2 and HCl at 0 to 5 degrees Celsius.
Okay, okay. Instead of that, they just put.
Yeah. Okay.
Okay. Yes, sir.
So B
Yes,
is
sir.
B option correct answer. Okay, now come to this question number 7.
Option B, sir.
Good. 3 degree. Free radical is most stable one, right?
Yes, sir.
Sir,
Yes, please.
so why isn't option D correct?
Option D is this one. Okay. Option D. Methyl, this chlorine, this is also tertiary, and from the here also hydrogen can be removed. Okay. Not easily, because the cyclic compound normally do not undergo it. It can take place. It can be D also, right?
So they are major
Hmm.
isomer.
So why that one first? Yes. Here we have a steric hindrance, and here we have less steric hindrance. Here we have more bulky group around itself, but here we have less bulky. That is why possibility is remove the hydrogen from here.
Oh, okay, sir.
Hmm. Eighth question.
Oh, option A, sir.
Option A.
Yes, sir.
Everyone, everyone. Nakul,
Yes, sir.
Ryan, yeah. Alekhe, who's there? Wait, yeah. Aklian, Anshul, everyone clear?
Yes, sir.
Yes, sir.
All right. I'm sharing my screen with you. Okay, now. Ninth question.
C.
Yeah, good. What do you call this reaction?
Mercuration,
Also,
demercury.
It is called as a Schwarz reaction.
Oh, okay, sir. Sorry.
Okay, now number 12. Yeah,
D.
good. Tell me the basic funda here.
So beta
Marconi rule.
Mark.
Markovnikov rule. The positive part of addendum goes to carbon atom which has more number of hydrogen and negative to the one which has less number of hydrogen. 13th question. This is a special case where it will go by the SN2 type of mechanism. It's an inversion of configuration. You can remember this.
Okay, sir.
14th question.
B.
Yes. B. 15th question. The number of structural and configurational isomers of bromo compound found with the addition of HBr to pent2-ine. Okay. Here we have 1, 2, 3, 4, 5 pent2-ine. Now I am adding HBr here. How many structural and configurational isomers are possible for this?
So what is configurational isomer?
Geometrical, we can say geometrical, we can say optical.
Yes.
So here we can consider about the geometry, because after HBr addition, it will lead to the formation of a double bond with
Yes.
halogen, right? Should I go tell you?
Just 1 second, sir.
Okay.
So I think it should be option D.
Let us try. Pent 2-ine. 1, 2, 3, 4, 5. Pent 2-ine. Just add here HBr. 1, 2, 3, 4. It can be like this way, or it can be like this way. Got it? Two structural isomers are possible.
Yes, sir.
Okay. Now, what about their uh, can I draw this structure like this one? Double bond here, CH3 here, H here, CH2, CH3 here, and Br here. Can I say it's E and Z isomer are possible?
Okay, in that terms.
Yeah, that's
Yes,
what I'm
yes,
saying. If it had been too similar, too different, then I would have said that it is a cis and trans.
yes, sir, yes.
But here all the four are different, and I can say it is a E and Z isomer. So E and Z isomer from this side, and what about this one? Check. Are they the same thing? CS3Br? No, different. And 5 carbon chain.
C2H3.
Yeah.
H.
So it's also E and Z isomer.
Yes, sir.
So
So what
two.
is E and Z
Yeah,
isomer
I'll
again?
tell you. I'll tell you. Understand. 4 plus 2. 2 structural, 4 isomer. 4. So 2 and 4. Now, I can discuss that E and Z. First of all, I have come to the conclusion answer for 2 and 4. Now, I'll tell you what is E and Z isomer. If all the 4 atoms or group of atoms across the double bond are different, in that case, we not call it cis or trans, but we'll give it name as a E and Z. Among these two, methyl and hydrogen, one is given higher priority, other is given low priority. I'll come to the that structure. Suppose I have now say A, B, C, D. Higher priority, low priority, higher priority, low priority. Let it be. Then both the higher on the same side, both the low on the same side. In that case, we call it a Z isomer. But in case it is A, B, C, D, like that, higher and higher opposite here, lower, lower opposite here. In that case, we call it the E isomer. But how to give higher and lower priority? For that, we have a rule known as a SIP rule, CIP rule. Based upon the name of the scientist here, Can Ingold Prelog. That rule says that if higher the atomic number, more the priority. Here we have the carbon that is bonded here directly. Atomic number 6, higher priority. Lower priority because hydrogen is bonded here. Atomic number 1. Here bromine atomic number is 35, right? Here atomic number is 6 only. So it is given higher priority, lower priority. So this is a E isomer. Got it now?
Yes.
E for antagonon. Antagonon means opposite. Antagonon means opposite. And if it is like this, bromine here and this here, then higher both on the same side, lower both on the same side. In that case, it is a Z isomer. Z stands for Geusamen. Geusamen is means same. It's a German word which means same. So E and Z, if higher priority are on the same side, low priority on the same side, it is a E. Understood?
Yes, sir.
Right. Now come to number 16th question. Ethylene. Ethylene means CH2 double bond CH2. Ethylene is a common name of ethene. Yes. What product you will get here now? This one?
Yes.
A option.
Yes.
Next question.
Sir.
Yes.
So, but it's not given that there's like carbon tetrachloride as a catalyst, right? Only then this reaction will take place, right?
No. That is taken in the presence of bromine. Bromine plus carbon tetrachloride. With a chlorine, tetrachloride is not required.
Okay, okay.
Yeah.
No, B, right?
Yes. The one that is a better nucleophile. Yeah. Okay. Yeah. I have a butane here. From the butane, I have got the 2-chlorobutane. You can see it is a chiral carbon atom. It means that will be optically active. But that can be chlorine from the either side, right? So both will be
Yes.
formed, racemic mixture will be obtained.
So what is mesoform?
Mesoform means when the two similar group are on the same side. I told you somewhere in the topic of the resin. Wait. If the OH group are both on the same side, this compound is called as a mesoform. But in case I can say two similar group are on the opposite side and yet it is optically active, this is a dextroform or the levoform, right?
Okay, sir.
So we
Yes.
can this mesoform will be having planar symmetry and will be optically inactive. It will be
Yes.
optically inactive, right? But here we don't have planar symmetry and it will be optically active. Dextro or levo will be there.
Yes, sir.
Understood? You should recall.
Yes.
Okay. 19th question. Yes. Chlorobenzene is obtained by commercially by, remember it's a Rastrick process. Right now it's not in your syllabus right now. Leave it.
Okay, sir.
Number 20. Identify Y here. Oh, very simple question.
Sir, A.
A, sir.
A. Hmm. 21.
Sir, A.
A, sir.
Yes. Yeah. Next. By all of this. It can be done with all of this. Standard actions are there. Okay. Now, 23rd. Chlorine. At all the points, the chlorine can be attached here, right?
Yes, sir.
So it will be all D. 24. There's more than one correct answer. So chlorine here, D or Cl, D or H? H. That will be more reactive. But no reaction. No, 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 no. Wait. Which hydrogen to be removed now? Okay. Chlorine, alcoholic AOH, double bond. Yeah. First of all, remove this with the chlorine and then alcoholic AOH. Bi will be formed or third will be formed. Third and fourth B option. Got it now? This alcoholic OH will cause a dehydrohalogenation. So any one of this can take place. Right. Okay. So that's all for now. See you next week, and we'll be discussing your test paper that will be given beforehand. You do your best, and next week we will discuss your test paper as well as the topic related to that. Right. Okay then.
Yes.
See you next week. Goodbye
Thank
for
you,
now.
sir.
Right. ना बाहर मिला नहीं